this is a match pairs test problem. Let's read the problem first. Treatment X for reducing pain. A study was conducted to investigate the effectiveness of treatment X in reducing pain. 10 people were randomly selected. Their pain scales are recorded in the following table. 1 for before, 1 for after. The significance level is 5%. So that is your alpha. My question is, do you have evidence to prove that treatment X is effective in reducing pain? So let's take a look at the data. The first row is ID, so we don't need to worry about that. This is a match pairs test because we have two dependent samples, one for before, one for after. Why are they dependent? So here is why. For the first person, the 5 and 8, they both belong to the same person. So that's what do I mean by dependent. Now, the question is, you are trying to prove that this treatment is effective in reducing pain. 5 is a pain scale, 8 is a pain scale, and then you define the difference to be before minus after. So 5 minus 8, that is equals to -3. Now, if you just make a comparison, 5 and 8, is that a success? Before the treatment 5, after the treatment 8, so that one is not a success because after the treatment, the patient felt more painful, right? Same thing for number 2. Before was 7, after was 10. So after the treatment, the patient felt more painful. So that is not a successful case. And then the third one and the fourth one, are these two a success? 9 and 4, that is a success. 10 and 5, that is a success, right? Because after the treatment, they feel less painful. Same thing for the rest of the patient. So from patient 5 to patient 10, after the treatment, they felt less painful, right? Okay, so the next step is you have to state the alternative hypothesis. They are trying to show or prove that the treatment is effective in reducing pain. So you define the difference equals to before minus after. So this is what you have to think, and you have to think really, really hard in this case. That's what makes the match pairs test so difficult. Are we looking for, do you want this to be greater than or equal or less than 0? So here is what you have to think, you process in your mind. So you are trying to you have to give yourself a success. So let's say number 3. 9 minus 4. So 9 minus 4. So that if that is a success, that means before I am looking for a big number. And then after I am looking for a small number. So big number minus a small number must be greater than 0, right? Just like what you have in patient 3 to patient 10. If you take a number from before, subtract the number on after. So let's say 9 minus 4, 10 minus 5, 8 minus 0, 8 minus 2. They are all greater than 0. Because you expect to be very painful before the treatment and not too painful after the treatment. So a big pain scale subtract a small pain scale must be greater than 0. So that's what you put in your HA. So in your HA, the mu difference has to be greater than 0. And then for the H naught, since the problem didn't give me anything, I will just say the difference is less than or equal to 0. So now H naught and HA is done. You are ready to input the data to your calculator. So you hit the stat button, and then you will go to the edit. So stat edit, and then first you put before in L1 and then after in L3. So if you look all the way down on my calculator, make sure L1 and L2 has the same length because you don't want to type an extra number in the next row. Otherwise, if you have one extra number in row 11, once you perform the subtraction, the calculator will return an error. And then how do you perform this subtraction? So let me just clean up the data for you. Clean up the data on my L3. So on my L3, I put the cursor on L3 and then hit clear and then hit enter. So that's how you clean up the entire column. And then to perform the subtraction, you move the cursor. Do you see this? The blue cursor. So you move that to the top of L3, you click second 1 to type L1 minus second 2 to type L2. Once you click enter, the differences are there. So the first two differences are negative. That means they are not a success, right? Before was painful. Because after the treatment, the patients felt even more painful, right? And then in the rest of the differences, they are all positive. And we do have 1, 0, right? 6 and 6. 6 minus 6 equals to 0. That means that the treatment didn't do anything. Okay, now let's perform the test. So we are going to run a t-test on L3. Why do we run a t-test? How come we don't run a z-test? Because you don't know the population standard deviation sigma. So use t. So this is unknown. So unknown sigma. And then we will be using the t-test, a one sample t-test. I know this is a two sample problem, but we already combined the two sample into one line of data. So we will be running a one sample t-test. So you go to stat, and then you go to test, and then you click t-test. So I have the data. So if you look at the right side of my screen, you see that that's the screenshot that you're supposed to go through. So stat test, you click t-test, and then this is a data problem, so that's why I hit data, and then the mu naught is equals to 0. That's what you put in h naught and ha, and then you put the difference in L3, and then the frequency I always leave that in 1, never change that, and then the next line is very important. So do you see that on the right, on my screenshot, the one on the right hand side, do you see that I wrote ha mu is greater than 0? I want to tell you that sign option is for HA. The calculator needs to know that because that determines the p-value. HA, that sign determines everything. The sign determines the p-value. Left side, right side, or two side. All right? You have to pick the right one. So since we use a greater than, then you use a greater than. There is no equal in HA. And then once you hit calculate, you will get the t value and the p-value. So this one, the t value is equals to what? 2.703. I usually use 3 decimal places for the t, and then the p-value, what is that equal to? That equals to 0.0121, right? So 0.121, that is less than 5% alpha. So where is the 5%? That is written on the third line of the problem statement. The significance level is 5%. So since the p-value is less than alpha, what do? We reject h naught, right? So we reject h naught. So that means HA is true. That means treatment X is effective. So that's the conclusion. Treatment X is effective. HA is true. And then in some questions, they might ask you this: what is the p-value mean in this problem? So what is that mean in this problem? Allow me to type that. So what is the p-value mean? So what is the p-value mean? So what is the p-value mean in this problem? What does that mean? So the p-value means if h naught is true, this is what you have to say, assuming the null hypothesis is true, there is a chance equal to the p-value, which is 0.0121, that the alternative hypothesis is true, that the pain scale reduction after treatment X, treatment X is greater than, since you say h naught is true, so I know there is greater than HA, there is no equal in HA, but you assume h naught is true, then you have to take the equal as well, greater than or equal to the x bar. Where is the x bar? The x bar is 3.4. So this is the x bar. X bar is the average of L3. Okay. And then we will be moving on to the confidence interval. So for the confidence interval, this is a 5% alpha, right? So this is a 5% alpha. So we have a 5% alpha. Then we have to construct a 95% confidence interval. So the confidence interval, what you have to do is you have to go to stat test, and then this time you have to do a t interval. Do you see my screenshot? T interval. And then data, I put my difference in L3, secondary, L3, and then the confidence level is 95%, and then you hit calculate. So this one I have, what do I have? I have 0.55451 comma 6.2455. So this is my 95% confidence interval. There are two things you can say. The first one is explain what that means. So to explain, this is the correct language. We are 95% confident that the average pain reduction after treatment X falls between, let's put it down here, between, let's round this a little bit. How about this? 0.6 and 6.2. So you go see a doctor and then you get this treatment. So on average, after the treatment is done, expect to reduce 0.6 to 6.2 point in pain scale. And then the next one is my favorite. The next one is I call this a verify. This one, I like this one a lot. So for verify, you have to recall your H0. So let me just handwrite this. You have to recall your H0. So what is your H0? Your H0 is the mu difference. Let's take that. The mu difference is less than or equal to 0. And then this is your confidence interval, right? So is the 0 and the less than means negative, right? Is 0 and negative inside or outside the confidence level? Do you see 0 between those two numbers? No. Do you see negative between those two numbers? So that means this less than or equal to 0 is outside the confidence interval. Outside the confidence interval means H0 is not true, so we can just reject it. So H0 is not true. So we can just reject H0. Now you can check. I call this verify, right? I am trying to use the confidence interval to make a verification to support my conclusion. So do you see that we reject H0 in here? So the first reject, we use p-value to reject H0. And then the second reject, I use a confidence interval to reject H0. So that means after I finish the hypothesis test, I'm going to build one more confidence interval to support the conclusion that I just made. So I make one conclusion. I want to do one more job to support myself. And then this, I call this a verification. You have to verify the conclusion you made is true. And then regarding the graph, sometimes when you do homework online, they might ask you to do a graph. So the graph is right over here. So since HA is a mu greater than 0, so this is a right-sided test. So you see that the shaded region, the p-value is on the right-hand side, and then the cut, the place where you cut the t, is 2.7. That is also on the right-hand side of the axis, because right in the middle, we have a 0 over there. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video in any social media for me. Click the subscribe button if you are new to the channel. I highly appreciate your help. I will see you all in the next problem. Signing out.